Hello, my name is Taewon Kang. I am an undergraduate student from the Department of Computer Science and Engineering at Korea University. I would like to introduce some of my recent work regarding image-to-image translation, multiple GAN inversion for exemplar-based image-to-image translation. First, we need to understand how image-to-image translation works. Take a look at the following example. The sunny road image on the left is translated to a rainy road image. However, how can a machine translate a day image to a rainy image? This would be an example of what an image-to-image translation problem is. In image-to-image translation, our goal is to map an input image from one domain to an analogous image in a different domain. Image-to-image translation has many other practical applications. Many computer vision problems, such as inpainting, star transfer, super resolution, and colorization, can all benefit from better image-to-image translation. It can be viewed as a specific case of translating an image from one distribution to another, just like transferring a black and white image to a color image. Exemplar-based image-to-image translation is a kind of image-to-image translation which makes use of a structured image and a style image to generate output. Most recent approaches for this task have achieved steady progress by leveraging deep CNNs due to its high capacity. However, at the same time, it requires a large-scale paired domain dataset which has limited applicability. In exemplar-based image-to-image translation, CoCosNet is held in high regard because of its ability to produce state-of-the-art results. However, despite the success of CoCosNet in this endeavor, it exhibits several critical problems. Firstly, training rates are required, leading to expensive computation costs. Secondly, such training rates are mandatory for each and every task alongside large-scale training sets. Additionally, the spate block inside the CoCosNet network requires labeled masks for the training set, leading to restrictions in the practical use of the model. Finally, CoCosNet fails to match instances within a pair of images and causes the generated image to be overfitted to the mask image. GAN inversion aims at generating an image by solely optimizing a latent code of pre-trained GAN models, PGGAN or StyleGAN. Recently, traditional methods make use of a single latent code, therefore they have a limitation in representing diverse styles. Recently, mGANprior uses multiple latent codes but fails to predict optimized hyperparameters in each image, which we solve in the paper. In this paper, we explored an alternative solution called Multiple GAN Inversion for exemplar-based image-to-image translation. To overcome the aforementioned limitations for exemplar-based image-to-image translation, Multiple GAN inversion refines the translation hypothesis that self-decides to decipher the optimal translation result using warped image in exemplar-based image-to-image translation. Applying super resolution with GAN inversion, we generate high-quality translation results. The model runs the translation from the source domain to the target domain. We want the generated output to conform to the content image while still resembling the style of semantically similar parts in the style image. To address this problem, we first establish a correspondence between source and target in different domains, and then warp the exemplar image accordingly to match the meaning with the sources. After that, we refine the warped image, which is generated by cross-domain correspondence networks. In order to generate a more natural and plausible image through the proposed multiple GAN inversion, this is done using a self-deciding algorithm which decides the hyperparameters for GAN inversion. This figure shows our pipeline of exemplar-based image-to-image translation. We first summarize the implementation details of our approach, especially in cross-domain correspondence networks and multiple GAN inversion. In the Correspondence module, we used the CoCosNet default setting for experiments. We used an algorithm solver with beta 1 equals 0, beta 2 equals 0.999. And following the TTUR, we set invariance learning rates 1 exponential minus 4 and 4 exponential minus 4 respectively. For the multiple GAN inversion module, we basically try to follow the default settings of mGANprior with some modifications. We hypothesize composing layers ranging from 4 to 8, number of the valence codes ranging from 10 to 40. The upsampling factor is 4 for processing 256 square to 1024 square images. We used PGAN multi-Z as target rows in mGANprior. For the distance function, we used L2 and posterior rows as in mGANprior. We used a batch size of 1. We used two kinds of datasets to evaluate our method, namely Cerebral HQ and Frechet Faces HQ dataset. During the optimization, input images were researched into 256 square. We compared our method with recent state-of-the-art exemplar-based image-to-image translation methods such as CoCosNet, OEFT, image-to-star-GAN, and star transfer. In addition, we also evaluate our GAN inversion module in comparison with mGANprior, PERS, and image-to-star-GAN, which are state-of-the-art in GAN inversion. This picture shows a comparison of our model with other existing exemplar-based image-to-image translation and star transfer methods on the Cerebral HQ dataset. Here you can see the given source and target images and translation results by star transfer, image-to-star-GAN, warped image, CoCosNet, OEFT, and our result. This assumes that our networks can translate local features as well as global features from both structure and style. This picture shows a comparison of our model with other existing exemplar-based image-to-image translation and star transfer methods on FFHQ dataset. This assumes that our networks can translate local features as well as global features from both structure and style and generates high-resolution images. This picture shows a comparison of GAN inversion result with existing methods on the Cerebral HQ dataset. Our model generates competitive results with the smallest computational cost. This picture shows a comparison of GAN inversion result with existing methods on a warped image. Our multiple GAN inversion result of warped image super resolution compared with existing methods. Our approach successfully generates the most realistic and clearest results. We have evaluated our multiple GAN inversion module in the past two slides, where we show that our generated results are more realistic and plausible than state-of-the-art models. For instance, our method better generates features including the eyes or wrinkles, as well as the overall structure, clearly outperforming the state-of-the-art methods. In addition, our approach has shown the ability to apply high generalization to unseen input images, in which the other previous methods often fail. The first table shows the quantitative variation result, which used Frechet Inception Distance to measure the performance between original dataset and generated image distribution. In the second table, we compare the original dataset and generated image distributions. In this section, experiments are conducted to evaluate the effectiveness of multiple GAN inversion networks of exemplar-based image-to-image translation. We evaluate the impact of each composing layer, ranging from 4 to 8. This picture shows the aberration study result. We used PGAN multi-Z rows for these experiments, and we fixed the number of valence codes to 30. We evaluate our multiple GAN inversion module's computation time with the state-of-the-art model, OEFT and CoCosNet. CoCosNet reported in their paper using 8 32GB Tesla V100 GPUs, and it takes roughly 4 days to train 100 FLOX on an IEEE 20K dataset. However, OEFT and multiple GAN inversion use online optimization and pre-trained GAN models respectively. Compared to OEFT, which takes 632 seconds using the Cerebral HQ dataset, our model takes 467 seconds. In addition, we also conducted our user study on 80 participants. This shows our user study result. In this work, we proposed a novel framework. multiple GAN inversion for exemplar-based image-to-image translation. Our model generates a more natural and plausible image through the proposed multiple GAN inversion, using a self-deciding algorithm in choosing the hyperparameters for GAN inversion. We formulate the overall network from the two subnetworks, cross-domain correspondence networks and multiple GAN inversion. Our approach applies high generalization ability to unseen image domains, which is one of the major bottlenecks of state-of-the-art methods. Experimental results showed superiority in the proposed method compared to existing state-of-the-art exemplar-based image-to-image translation methods. Thank you for listening.